So in this exercise, we're asked to find the percentage of towns with annual rainfall between 6.99 and 13.05 inches. We're given the same data that we were in the last Try It exercise, and that's this frequency table with intervals of annual rainfall in inches in the first column, and then frequency, relative frequency, and cumulative frequency for each one of these classes, each one of these intervals. Now, of note is that when we have between, that's kind of a loaded question. But we have it to take it in context of the data that we're given. The reason why I say it's kind of a loaded question is because you have the transition 6.99 and 6.99, 9.01 and 9.01. The upper bound of one interval is the lower bound of the other. And as we discussed in the last problem, that actual value is included in as the lower bound in the higher interval. So 9.01 is part of this fourth interval, not part of the third interval. That is the non-inclusive upper bound of the 6.99 through 9.01. So technically a problem like this, when it says between, it should indicate whether it means inclusive or exclusive. But in the context of this problem, if it was inclusive, well, we wouldn't be able to include the 13.05 because we don't know how many of these 5 values in that interval, the 13.05 through 15.07, we don't know. We don't have the data. We don't know how many of those values are 13.05. So we have to assume that it means non-inclusive. It doesn't include 6.99 or 13.05. So we're just looking at these 3 rows, 6.99 through 9.01, 9.01 through 11.03, and 11.03 through 13.05. And again, because of how we're given the information, there are several ways that we can go about this. The tried and true method is to just use the frequencies 15, 8, and 9 and divide by the total amount. So 15 plus 8 plus 9, and that's out of 50 total. 15 plus 8 is 23, plus 9 is 32, so that's 32 out of 50, which equals 64 out of 100. Now this indicates that 64% of towns, at least in our sample, have annual rainfall between 6.99 inches and 13.05 inches. Now another way we could do that is that we could look at the cumulative frequencies and we could subtract. We know that we have 0.90 for the cumulative frequency up to our last row that we're looking at, the last interval, 11.03 and 13.05. And we know that the cumulative frequency for the rows before the rows in question was 0.26. So we could also say that we could find the percentage of towns with annual rainfall between 6.99 and 13.05 inches by subtracting that first cumulative relative frequency from our last cumulative relative frequency. So 0.90 minus 0.26, and that does equal 0.64, which verifies that this is our solution, 64%. We could also use the relative frequency. Now, if you look at the relative frequencies for those columns, we have, or for those rows, this row right here, and row right here, that indicates between 6.99 and 13.05. Well, we have 0.30 plus 0.16 plus 0.18 for the relative frequencies for those individual intervals. And if we add those up, this equals 0.46 plus 0.18, which does equal 0.64. So using all 3 methods with the information we have in this table, we can say that 64% of towns have annual rainfall between 6.99 and 13.05 inches.